Hello, guys. I hope the audio is audible now. Let me know if everything is all right. Okay, so on the last day, what did we discuss? We discussed about methods of finding roots. We basically discussed two methods. One is the method of bisection, another one is Newton-Raphson method. Both of these methods are used to find roots. And today, in this session, we'll be discussing the second part of this numerical analysis techniques, and we'll start with the interpolation technique. Now, there are mainly three types of interpolation which we will be dealing with. One is Newton's forward interpolation, another one is Newton's backward interpolation, and another one is Lagrange's interpolation. So these three interpolations we'll be dealing with today, and if time permits, we'll also go for numerical integration. Okay. Good morning, Harry, Murli. Now everything is all right? Just let me know, Harry, Murli. Where is Ajay today? What is interpolation? In interpolation, you will be given a set of values. Means values of y at different values of x at an equal interval. Remember this thing. At an equal interval, you will be provided some values, and you may be asked to find out values at some other places which are not given in the table. Now, when you find the values near the beginning of the table, that is called Newton, that is dealt with Newton's forward interpolation formula. When you find values at the end of the table or after the end of the table, that is dealt with Newton's backward interpolation formula. In Newton's forward interpolation and backward interpolation, the values of x remains constant. Okay. So this is valid for equal interval, but for Lagrange's interpolation formula, the values of x are not equidistant from each other. Okay, so we'll talk about them one by one. Let's say you are given a set of values of y for different values of x. So you are given, let's say, a table like this. Okay, this is where we have used the value of, let's say, x. Here the corresponding value y is equals to f of x. Now, corresponding to different values of x, we'll find different value of it will start from x0, x1, x2, x3, x4, x5, x6, and so on. Okay, so should write it in this way, x4 and so on. Let's say n number of values are there up to xn. Correspondingly, the values of y, y0, y1, y2, y3, y4, so on up to yn. So the method, just write the definition of interpolation. Method of finding y corresponding to any values of x between x0 and xn. x0 is the first value, xn is the last value. is known as interpolation. Now let us take the first interpolation formula, Newton's forward interpolation formula. Newton's forward interpolation formula. So this Newton's forward interpolation formula is used to find the values of y near the beginning of the table. So the method is known as interpolation, and when you use it as a verb, we call it interpolate. So it is used to interpolate the values of y near the beginning of the table. Near the beginning of a set of tabulated values. Near this, and when we write the value Pn of x, value of this function at that particular value of x, where you need to find out the values, it is given by y0 plus u times delta y0 plus u into u minus 1 divided by 2 factorial delta square. You see, here we are showing the triangle in this way. Okay, this is the normal triangle, not inverted. Two types of triangles we can draw. So for forward interpolation, this kind of triangle will be used, and another kind of triangle may be used later. For the time being, we are dealing with the first one, u into u minus 1 by 2 factorial delta square y0 plus u into u minus 1, then u minus 2, and in the denominator, whatever will be the factorial, u minus 1 unit less. Okay, so here you can see it is 2 factorial, so u minus 1, y minus 1, 3 factorial, so the last term is u minus 2. Here it will be delta u y0 plus so on. Let us write the nth term. Nth term will be u into u minus 1, u minus 2, u minus 3, and so on up to u. Look here in the denominator, what will come? Let's see, if I am writing the nth term, so here n factorial will come. See here u by 1 factorial, 2 factorial. So if I write n factorial, obviously here u minus n minus 1 will be there. Okay, u minus n minus 1 will be there. So this becomes u minus n minus minus plus. Is it understood? Here 1 unit less is used. So u minus within bracket n minus 1. So if you remove the bracket, it becomes u minus n plus 1 delta to the power n y0. Now here we have used this differential. These are called forward differences. Delta y0, delta square y0, delta cube y0, delta to the power 4 y0, and so on, delta to the power n y0. So these are called forward differences. So to find out these values, we need forward difference table. Another thing is y0, you can easily know from here. What is u? U is unknown here. So let me tell you what is u. U is the common interval. Where x is equals to x0 plus u h. So from here u is equals to x minus x0 divided by h. This formula will be used. So as you can see, what is u? Let's say you find the value of x naught, then you increase by h amount, get x1, again you increase h amount, you get x2, again you increase by h amount, you get x3, and so on. Okay. So what is u? Let's say you are not given x5. If you want to go x5, what will you do? If you want to go, let's say, up to x5, here you want to go, what you gonna do here? You want to go to x5, what you gonna do? You need x naught plus h. So 5 times you need to add h, then you will reach to x5. Okay. So here, then at that case, u will become 5. Getting it? Good morning, Deep. Here you can write it within bracket that here the intervals are equal between the values x value. Y values may not be equal, but x values are equal. Now to find out these values of delta y0, del square y0, delta cube y0, we need to make forward difference table. So it's a very easy thing, forward difference table. Let us make this forward difference table. Make a table having 7 columns and okay, let's make it like this. Here we need to make it 7. We need to make 7 columns. 4 columns here will make. Okay, let's go for it. This is x, this is y. Then we'll be getting delta y. So let's write the value of x. It is x0. If we add h, it becomes x1, x2, x3, x4, x5. After x5 you write the corresponding value of y will become, so y equals to fx, y0, y1, y2, y3, y4, y. Now when you calculate delta y naught, delta y, from this you will get values, from these two you will get values, from these two you will get values, you will get values, from you will get values. So what will be delta y? Delta y is y1 minus y0. So delta y0. See, the first symbol will be used. Delta y0 means y1 minus y0. Delta y1 means y2 minus y1. Delta y2 means y3 minus y2. Delta y3, y4 minus y3. So this will be delta y4, y5 minus y4. Okay. So from this we get the value of delta y. Now the next value we can find out. Once you find out delta y, we can find out delta square y. Okay. So you will be taking those two sets, these two values, these two values, these two values. From this you will be getting delta square y0. Delta square y0 will be delta y1 minus delta y0. Delta square y1, then here you will be getting delta square y2, delta y3 minus delta y2. Here you will be delta square y3. Okay. Now from this we can find out delta cube y. Delta cube y will be evaluated between these two values, these two values, these two values. So delta square y1 minus delta square y0. So delta cube y0 will be delta cube y1 will be delta cube y2. So that is delta cube y. Next you will be getting delta to the power 4y. So this value will be evaluated with two values. So this will become delta to the power 4y0, delta to the power 4y1. Ultimately delta to the power 5y. So from this becomes delta to the power 5y. Okay. So one thing you notice here, what you require delta y0, delta square y0, delta cube y0 means you require the first of these values, isn't it? We are basically in need of these values. And in the backward interpolation you will see you will be requiring these values below this. In backward interpolation you will see these values will be required. So is it understood, everybody? In the forward interpolation we need y0, we need delta y0, we need delta square y0, we need delta cube y0, we need delta to the power 4y0 and delta to the power 5y. So you can also write as a note here, may forget, so it is better if you keep a note. Here you can write a note. So delta y0 is equals to y1 minus y0, delta square y0, delta y1 minus delta y0, delta cube y0, delta square y1 minus delta y0, delta to the power 4y0, the cube y1, the cube y0, delta to the power 5y0, delta to the power 4y1 minus delta to the power 4y. Now in Newton's forward interpolation formula, we need to there are some requirements, two requirements. First requirement is that the interval between these two values, any two values, are equal. So you can keep it right, you can keep it like a note or condition. Number one, the interval between two values, consecutive values of x, should be equal. This is the first criteria. Second criteria being the given function f of x should be an increasing or decreasing function of x. Okay, so it should not be a constant function. If it is a constant function, then there is no meaning of applying this. It must be some increasing function or decreasing function. Or yeah, any question from this? I forget about my tea. Cold tea it has become. Let me give you a problem. Let's start with a simple problem. So you are given a table like this. Given x and f of x 1, 2, 3, 4. These values will be always be equidistant for forward interpolation. 1, 7, 17, 31. What is the value of f of x at x equals to 1.5? Okay, let me give you options. Option 1, 2.5, 3.5, 4.5, 5.5. Do it quickly. Where is Ajay today? Ajay has not come. Deep is attending it live after a long time, na? What is h here? H is equals to 1, right? 1, 2, 3, 4. So h is equals to 1. X0 is equals to 1. X is equals to 1.5. So u equals to x minus x naught by h, 1.5 minus 1 by 1. So it is 0.5. Okay. Now it's the time to formulate the forward difference table. So let us formulate the forward difference table. Okay, will it be allowed to put here? So we are formulating the forward difference table. So the values of x, values of f of x, right here. Delta y values we will write here. Delta square y values we will write here. So from 4 values, how many values you can expect? It is 1, 2, 3, 4, 1, 7, 17, 31. So from this you can see 7 minus 1 is 6, 17 minus 7, 10, 31 minus 17. So it is 14. 10 minus 6 is 4, 14 minus 10 is 4, and another term will come, the cube, 4 minus 4 is. So are you getting the forward difference table in this way? This is our forward difference table. So f of 1.5, what was in the formula? Y0. So y0 here, you see these values are utilized. This is your y0, this is your delta y0, this is your square y0, cube y0. If of 1.5 is y0 means 1 plus u into delta y0, u is 0.5 times delta y0 is 6 plus u into u minus 1 by 2 factorial delta square y0 means 4, and the other terms will be 0 because delta cube y0 equals to 0. So what are you getting? See, the first 2 values are positive, but the third value is negative. अच्छा, minus 0.5 है ना, तो अच्छा. 1 plus 3 is 4 minus here 0.5 is coming. Is it done, guys? Tell me. Just let me know when you are done, then we'll go for another problem. Option B. Okay, hello. Try to do this problem. Simple thing. This came in December 2016. Given that sine 45 degree equals to this 50, sine 55, sine 6, approximate value of sine 52. So you can consider it in this way. Just ignore the sign. Just consider it like this: 45, 50, 55, 60, and corresponding values are this. So first of all, you need to make the forward difference table. Make the forward difference table. In the place of x, you will write 45, 50, 55 and 60. In the place of y is equals to f of x, you will write the values of sine: 0.7071, 0.7660, 0.8192, 0.866. Then you find delta of y or delta of fx, delta square fx, delta cube. So from 4 values we can go up to delta cube fx. Yes, do this one. What is h here? As you can see, 45, 50, 55, 60. So h is equals to 5. है ना? Give it a try. Could you find the result? Okay. So from these two 0.7660, 0.7071, what do you get? 0.0589. From these two, 0.0532. So you see the difference is positive. So bigger number, smaller number. So you are getting a positive value. Now from these two, you see this number is less than the first number. Here you will be getting negative value, minus 0.0057. Okay, after minus before, see like that. From these two, you will be getting minus 0.0007. So the required values are, this is your y0, this is your delta y0, this is your delta square y0, this is your delta cube y0. So if you get it convenient, you can also write so that don't get confused. Okay, so what is h here? Here h is equals to 5, है ना? And what is x? X is 52 degree, so x is 52, and x0 is 45. So what is the value of u? X minus x0 by h. So this is equals to 7 by 5. Which option are you getting, guys? Harry, Deep, Murli, which option are you getting? Therefore, sine 52 degree is equals to y0 plus u delta y0 plus u into u minus 1 by 2 factorial delta square y0 u into u minus 1 u minus 2 by 3 factorial delta cube y0. Up to delta cube y0 we have got, na? Yes. So other terms will be 0. So y0 here 0.7071, u times delta y0 7 by 5 times 0.0589 plus 1 by 2 u into u minus 1, 7 by 5, 7 by 5 minus 1, delta square y0 minus 0.0057 plus 1 by 3 factorial into u into u minus 1 u minus 2 delta cube y3. So 3 factorial is 1 by 3 factorial is 6 u into u minus 1 u minus 2 delta cube y0 minus 0.0007. Okay, and all other terms are, so the first term is 0.7071 plus, you calculate this, you get it 0.085, and this term will come negative of 0.0399 divided by 25. And look, you are allowed to use calculator, so you can easily use calculator and calculate the values. 0.0049 divided by 125. So if you calculate this with a calculator, you will get 0.788. So that is matching with option C. Is it clear, guys? Tell me. Let me know once it is done, then we'll go for the Newton's backward interpolation formula. So Newton's forward interpolation formula is used to find values near the beginning of the table, means in this region. When you go for backward, then it will be used to find a value at the end of the table. Okay. Write it quickly. Should we move forward? Next, give the heading Newton's backward interpolation formula. If you have understood the forward interpolation formula, backward interpolation formula, you can easily understand. The formula remains almost the same, only a slight minor changes are there. So this method, this interpolation method is used to interpolate the values of y near the end of the table, near the end of a set of tabulated values. Or a little ahead. Okay, you can go out of the table also. To the right of yn. So at yn, your table ends, but you can further find out values for, let's say, yn plus 1, which is beyond yn. So here the formula becomes Pn of x. So this is the value of y at the unknown value of x. This is equals to, look, in the forward interpolation formula we used y0, but here it is coming from the right. Okay, so let me just do one thing. So proceeding. Okay, let's copy this table. Okay, here you can see yn is the last values. So let me just do one thing. We are more interested in the end values. So let's write dot dot dot. Here you will be getting xn minus 1, yn minus 1. So we are basically interested in these regions near the end of the table. So here in this region we apply Newton's backward interpolation formula. So Pn of x, this will be, see the last value yn plus u times the definition of u will remain same. Whatever definition of u we have used before, that will remain same. Here instead of triangular yn, here will be inverted triangle. Okay, nabla yn plus, in the previous case we have used u into u minus 1, here it will be u into u plus 1 by 2 factorial nabla square. Here you see we are taking the values from the below, u into u plus 1 u plus 2 divided by 3 factorial nabla cube y n, and so on. Let us write the nth value. So u into u plus 1 u plus 3, it will go on, and yes, you see in the denominator we have n factorial, and as you can see here it is this value is 1 unit less than the factorial. Here you see u plus 2, so 3 minus 1. So here also it will become u plus n minus 1. Here delta to the power n y n. So if you, whenever you are learning, if you carefully observe the formula and try to understand the pattern, then it becomes easy for you to remember. Otherwise you will forget, you will mess up. You need to keep this thing in mind, like here every time plus is being used. Okay, and whatever be the factorial value, 1 unit less is used here. Previously there was a minus, so it became u minus n plus 1, but here it is plus only, so that is why u plus n minus 1. So try to keep in mind this very fine difference. So here also whenever you, okay, u here, u is x minus x0 by h. X is equals to x0 plus u into, this definition does not change. So let us formulate now. Here the table will be called backward difference table. Previously we call it forward difference table. Here that thing we will call backward difference table. We are taking the values from backward, so the corresponding table is known as backward difference table. Here ahead. Is it done, guys? Let us formulate the backward difference table. So make the table like we did before. Values of x, values of y. Here we'll be writing the first difference. Seven columns you make, that will be sufficient for us. X, y is equals f of x. First difference nabla y, second difference nabla square y, third nabla cube y, fourth difference, fifth difference. If I take up to y x5, then fourth difference will x0, x1, x3, 4 and x5 correspondingly values of y, y5, y4, y3, y2, y1, y0. From these two you will be getting values. So here you see y1 minus y0, this will be termed as delta y, not 0 but 1. Okay, we are taking the backward difference. Y5 minus y4 is y5, nabla y5. Here nabla y4, here nabla y3, here nabla y2. So try to observe these fine differences. Next, from these two you will get delta y5 minus delta y4, nabla y4 is nabla square y5, nabla square y4, nabla square y3, nabla square y2. From these two you will get nabla cube y5, nabla cube y4, nabla cube y3. Let me know if I make any mistake. I am doing it very carefully. y5. So in your examination also, look, these things are very simple, but you need to keep it accurate. Otherwise, you may get negative marking in part C. That is quite dangerous. In your examination, part A, part B, part C are there. For part C, you have to make it sure short. You cannot afford negative marking in part C. So whenever you attempt questions from part C, make it like whatever questions you attempt it like with 100% confident, and it's should be correct. Like if you attempt 10 questions, at least 9 questions should be correct. So in the forward difference table, we will be requiring these values at the end of the table. Okay, y5 you require y delta y5 you require delta square y5 you require delta cube y5 you require delta to the power 4 y5 you require delta to the power 5 nabla to the power 5 you require. So you require this one. Okay. Nabla y5 is equals to y5 minus y4. Nabla square y5 is equals to nabla y5 minus nabla y4. Nabla cube y5 is equals to nabla square y5 nabla square y4. Nabla to the power 4 y5 nabla cube y5 nabla cube y4 and nabla to the power 5 y5 nabla to the power 4 y5 minus nabla to the 4 y. Let me know once it is done, then we'll go for a problem. Is this nebula? No, not exactly same. Here it is denote. It is used to denote the difference. Okay, nebula is the backward difference. And in contrast, this delta, it is forward difference. So this is first backward difference, this is second backward difference, third backward difference, fourth backward difference, fifth backward difference. This is called nabla, this is called delta. I know you know the, I hope you know the difference. Let me give you a problem. This nebula and delta is different than we generally use to calculate gradient or Laplacian or all those. That is not same. So in a table, you are given this following data. So you are given year as X, population in Y, it is given in thousands. Okay, means in the year 1891 the population of let's say city, it was 46,000. In 1901 the population was 66. 1911 It was 81. 1921 movie was there, na? In the name 1921, 93, 1931. It is 101,000. What was the population? What was the population in the year 1925? The given options are 94, 97, 98, 9,000. Acha, what was the population in year 1920? Acha, in thousands. Do it quickly. Is it getting solved? Tell me the answer quickly. This should not take much time. Let us make the table first, backward difference table. we have the values of x, then values of y, then nabla y, nabla square y, nabla cube y, then nabla 4y up to nabla to the power 4y may require 1891, 1901, 1911, 1921 and 1931, and the values of y are 46, 6, 81, 93, 104. So from these two, it is for 66 minus 46, 20. It is 81 minus 66, 15. 93 minus 81, 12. 101 minus 93 is 8. From these two is 15 minus 20 minus 5 minus 3 minus 4. From these 2 minus 3, so it is plus 2 minus 1 minus 3. Okay, what answer are you getting? So you require this is as y0, this is nabla y0, this is nabla square y0, this is nabla cube y0, this nabla 4y, sorry, yn. I written it correctly. थोड़ा सा गलती हो गया दोस्तों. Okay, so the value of y at 1925. Before we calculate the value, let us find out what is u. What is u? Here x is equals to 1925, xn is equals to 1931, u is equals to x minus xn by h. 1925 minus 1931. What is the difference? 91 to 1901 मतलब 10. Common interval is 10 minus 6 by 10 minus 3 by 5. So we know the formula now. 1925 will be yn plus u times nabla yn, u into u plus 1 by factorial nabla square yn, u into u plus 1 u plus 2 by 3 factorial nabla cube yn. Another term, let's write u into u plus 1 u plus 2 u plus 3 by 4 factorial nabla to the power 4 yn and so on. Only the first 5 values will remain, other values will be 0. So yn is 101, just put the value 101 plus u is minus 3 by 5, nabla yn is 8 plus u into u plus 1 minus 3 by 5 minus 3 by 5 plus 1 by 2 delta nabla square yn minus 4 plus minus 3 by 5 minus 3 by 5 plus 1 minus 3 by 5 plus 2 by 6 nabla cube yn is minus 1 plus minus 3 by 5 minus 3 by 5 plus 1 minus 3 by 5 plus 2 minus 3 by 5 plus 3 divided by 4 factorial. 4 factorial is 24. Nabla to the power 4 yn is minus 3 and all other terms are 0. Okay. Now we just need to simplify and calculate. First term 101 minus 24 and you see 2 and this is 2 minus minus plus, so 3 by 5 1 minus 3 by 5 into 2 by 5 multiplied by 2 plus, you see minus minus plus 3 by 5 2 by 5, 2 minus 3 by 5 is 7 by 5 and this 1 by 6 is remaining, and here you see minus minus plus 1 by 3 and 24, so 1 by 8, 3 by 5, 1 minus 3 by 5 is 2 by 5, then 7 by 5, 15 minus 8, अच्छा 15 minus 12 by 5. Okay, and 0 is not counted here. This is equals to, so if you calculate this whole sum expression, look, you need to simplify. Okay, once you simplify it, it will be easier for you to calculate with using a calculator. You will be given a calculator in your examination, and even if you are not given a calculator, you can easily find it. So this is the question from the time where calculators were not allowed. Okay, so at that time what people used to do, they used to calculate a rough value, so it will come around 96.874, so we can take around 97, option 2. Is it clear, guys? Equidistant values. One last interpolation technique is remaining, that is Lagrange interpolation. So what is the difference between this Newton's interpolation and Lagrange interpolation? In Lagrange interpolation, the given values are not equispaced. Here, as you can see, the examples we have done, here the values are equispaced. The difference between the values are same, but for Lagrange's, the values will be different. So we can in one way say that Lagrange interpolation is more general than this Newton's forward or backward. So if you are done with this, have you done this? Have you written this? Can you move forward? Let's go for Lagrange's interpolation formula. here the values of x are not equispaced. So here also we are going to use the same table, but the difference is here the values are not equidistant. So for this we are defining, let's say, we are defining a function w of x, okay, which is defined in this way: x minus x0. X is the value where you need to find out the value of y. X minus x0, x minus x1, x minus x2. So these terms are in product, okay, x minus x0, x minus x1, x minus x2, and it will be continued up to x minus xn. W prime at x, what will be this value? You see, w prime of x, this will continue how many terms? This will give you n number of terms, right? You see, you take derivative, so it is derivative of u, v, w, x, y, z, and so on. So if you keep the first term, if you take the derivative of the first term, it becomes d dx of x minus x naught is equals to 1 into this whole terms plus 1 into the whole terms except x minus x1. What will be the third term? 1 into all the terms except x minus x2 plus 1 into all the term except x minus x3. Okay, so if I put w prime of x0, then how many terms you will get? You will get x0 minus x1. Look, for all the other terms x0 will appear, so if you put x equals to x0, so all the terms will vanish. So x0 minus x1, x0 minus x2, x0 minus x3, and so on, x0 minus xn. Do you understand this line or not? First tell me, then we'll proceed. First to imagine what would be w prime of x. Then you will get n number of terms. Once you put x equals to x naught, then only one term will survive, other terms will be all will be 0. So is it understood, Harry, Murli? You people got it? So this is for the first value. So for in general any value, let's say xi, so whatever value you will put, only one term will survive. So x0 if you have put, so x0 minus x1, so that term containing x minus x0, that term is not there. Okay, so xi when you use, what will be this value? You see, xi minus x0 will be there, there is no problem. Xi minus x1, there will be no problem. It will go on. Which value will not remain? Xi minus xi minus 1, this term will remain, but the next term, that is xi minus xi, that is missing. So the next term will be xi minus xi plus 1, and so on, xi minus xn. Is it understood or not? So using this third formula, the last formula here, You can find out any value. If you want to calculate, say, w prime of x2, for example, if you want to calculate w prime of, let's say, x3, what will be there? You see, x3 minus x0, x3 minus x1, x3 minus x2 will be there, but x3 minus x3 will not be there, so x3 minus x4 will be there, and so on. So x4, x3 minus xn. So I hope you understood this one. And hence, if you are given to calculate any value at x, it can be written in this way: w of x divided by, this formula is a little different, okay, x minus x0 w prime of x0 multiplied by y0 plus w of x divided by x minus x1 w prime x1 y1 plus w of x x minus x2 w prime of x2, prime is the derivative, okay, y2, and so on. Plus w of x, what will be the last term? X minus xn w prime of xn yn. Okay, so we can find a pattern. What is the pattern? That w of x, it is remaining at the numerator. In the denominator, what we have, x minus xi, let's say, w prime of xi into yi sum over I is equals to 0 to n. So this is the common formula. Here, this term, is known as Lagrange coefficient. When we will be doing a problem, then it will be more clear. I think now also it is clear. Have you understood the evaluation of w prime of xi, how it is coming? That you need to understand clearly, very clearly. If that is understood, then things are done. Okay, let's move forward for a problem then, if you have understood this one. Let's write this problem. You are provided a table like this, and the values of x and fx are given. Values of x and fx are given: 5, 7, 11, 13, 17, and as you can see the values are not equispaced. 5, then 7, it should have been 9, but it is given 11, then 13, then 17. So the values are not equispaced. 150, 392. The calculation will be a little bit lengthy, but it is okay. In your examination you may be given smaller values which you can easily tackle. What is the value of f of 9 using Lagrange's interpolation technique? So sometimes you may not be getting this Lagrange interpolation technique mentioned in the question, but by looking at the values given to you, you can easily understand that it is talking about Lagrange interpolation formula. 750, 810, 830, 910. So here in this case there is no problem, there is no such thing like backward difference table or forward difference table. Here what you require the values of x0, x1, x2 and all those things. Okay, so you need to find out this w of x, then w prime of x, w prime xi, all those things. Try to understand this very carefully. So this is our x0, this is our x1, x2, x3 and x4. Correspondingly, this is y0, y1, y2, y3 and y. So what here, x is equals to 9. So what will be w of x? It is x minus x0, x minus x1, x minus x2, x minus x3 and x minus x4. 5 values are given, 5 terms will come. So this is equals to 9 minus 5, okay, let's keep it like this. W prime of xi is equals to xi minus x0. Acha, there is no point in making this because we are given finite values, right? So let's apply the formula. We need to find out P5 actually, 5 values. So Pn equals to 5, na? P5 of 9. What was the formula? W of x by x minus xi, W prime of xi, I is equals to 0 to, here it is 4, right? 0 to 4. So how many terms you will get? 5 terms. Look, this will be quite big. W of x by x minus xi. So we can write, look, x, when you put I equals to 0, so x minus x0, the first term is cancelled for I equals to 0. When you put I equals to 1, means x minus x1, this term will be missing from W of x. So only 4 term will be there in the numerator, okay na? And W prime xi, this will also have 4 terms. So it is x minus x1, x minus x2, x minus x3, x minus x4 divided by, so x minus x0 is cancelled. So w prime of xi, it is how much? You see, xi minus x0, so x, this will be, acha, x0 minus x1, x0 minus x2, x0 minus x3 and x0 minus x4. Is it clear now? So one term we have missed, that is yi na, into y0 plus, for I equals to 1, in the denominator x minus x1, so x minus x1 will not be there, so x minus x0, x minus x, x minus 3, x minus. Look, in your examination they may not give you 5 values, they may give you 2-3 values, so then the calculation will reduce proportionally. Okay, so you don't need to worry that it is going to be very long. For the time being we are learning, so things can go a little bit lengthy, but it's okay. Here it is x1 minus x0, x1 minus x2, x1 minus 3 and x1 minus x4. So have you understood these first two terms? Can you write the third term then? Third term will be, correct me if I write anything wrong, x minus x0. So now we are putting I equals to 2, so x minus x2 will be missing. You need to practice this 2-3 times, otherwise you will mess it up. Okay, now this is easy, but not that easy that if you are not very careful, you will definitely make mistake. Just match it. You do it by yourself and match it with me. Multiplied y1 in the second term. Okay, so 5 term we have written. Now is the time to put the values. So x is 9. So 9 minus 7, 9 minus 11, 9 minus 13, 9 minus 17 by 5 minus 7, 5 minus 9, 5 minus 11. 5 minus 13, 5 minus 17, and the value of y0 is 150 plus. Here it is 9 minus 7, 9 minus 11, 9 minus 5. If you are not very careful, you will definitely make mistake. 9 minus 13, 9 minus 17. Okay, correct me if I make anything wrong. X1 is now 7, 7 minus 5, 7 minus 11, 7 minus 13, 7 minus 17. Value of y1 is 392. I am right. Let's write y2 7 के बाद अच्छा x 9 5 9 minus 7 9 minus 11 will not be there. 9 minus 15, 9 minus 4 terms divided by 7 we have taken, so 11 minus 5, 11 minus 7, 11 minus 13, 11 minus 17. The value of y is 1452. Okay, plus 9 minus 5, 9 minus 7, 9 minus 11, 9 minus 13 will be missing now, divided by 13 we are taking, 13 minus 5, 13 minus 7, 13 minus 11, 13 minus 13 is missing, 13 minus 17, this value is 2, 3, and it 2, 3, 6, 6. The last term, 9 minus 5 minus 7, 9 minus 7, 9 minus 13, 17 minus 5, 17, 7, 17, 11, 17, or 5, 0. Oh my god. What a lengthy expression, one page. Even one page is not sufficient. Now you calculate all these values. The first value 9 minus 7, 9 minus 11, 9 minus 13 by 9 minus 17 divided by this thing, this will give you 50 by 3. The second term will give you 3136 by 50. Now calculators are allowed, so you don't need to worry much. It is just a matter of time. It will take little bit time, so you can do it at the end after maybe 2.5 hours of your examination. But this can give you 5 marks. So for 5 marks, investing 10 minutes also is justified. 810 will come. So in this lecture we have covered all the interpolation techniques. In the next lecture tomorrow at 7:30 a.m. in the morning, we'll be like completing this numerical analysis. That will be the third lecture, and in that lecture we'll try to cover Simpson's method, then trapezoidal method, and Runge-Kutta method. Runge-Kutta, that is differential method, numerical integration and numerical differentiation. These two things are left, and another thing is small thing, finite difference method. So with that our syllabus will be completed. Other than that, Euler's method is also there. We also cover Euler's method. So interpolation, numerical integration, numerical differentiation, Euler's method, and finite difference method, and I think that is more than sufficient for your examination. And after that, one more lecture for group and tensor. We'll not go much deep in group and tensor because those things are purely mathematical thing, and we'll be doing very from the surface only. Okay, we don't need to go much deep in group theory or in tensor. So maybe in the next 2-3 lectures we'll be completing our mathematical methods, and after that we can start quantum mechanics. Okay, is it done? So if you are done, we can conclude the session here today. So see you tomorrow in the morning. Thank you guys, thank you very much for joining the session. If you are new to this channel, please subscribe the channel, don't forget to press the bell icon. And thanks for watching. Have a great day guys. Bye, take care.